All right, let's dive into something pretty wild happening in AI. We're going to talk about a totally new way of building models, one that moves away from creating a single, giant, all knowing brain, and instead builds a massive team of tiny, specialized experts. So, this is really the biggest question in AI right now, isn't it? We all want more powerful, more capable AI. But the old strategy of just making the models bigger and bigger, well, it's hitting a very, very expensive wall. The cost to run these things is getting out of control. We've got to find a smarter way to get smarter. Okay, so where is all that money going? Where's the bottleneck? Let's pop the hood and take a look at what's really going on inside these massive language models. Well, the main culprit is something called the feed-forward layer, or FFW. Get this, in a typical large model, these layers account for a whopping 2/3 of all the parameters. You can think of these FFW layers as the model's enormous library, where it stores all its knowledge. Now, here's the problem. Every time you ask it even a simple question, it has to activate and process that entire library. It's just incredibly inefficient. And this brings us to a fundamental trade-off. It's a real puzzle. On one hand, you want as many total parameters as you can get, because that's the model's knowledge. More is better. But on the other hand, the number of active parameters, the ones you actually have to fire up for any given task, that's what drives the cost. And for that, less is better. So the dream scenario? A model that knows a trillion things, but only has to think about a few of them to give you an answer. So how do we get there? Well, researchers have been chipping away at this by shifting their thinking, moving away from building one single super genius and toward creating something more like a specialist team. And that brings us to this idea called mixture of experts, or MOE. The concept is actually beautifully simple. Instead of one huge generalist network that tries to do everything, you create a smaller team of specialized expert networks. When a new task comes in, a little router figures out which expert is best for the job and sends the task its way. But, there's a catch. While Mo is a great idea, it has its own bottleneck. That router, the one directing traffic, it starts to get really overwhelmed if it has too many experts to choose from. This has pretty much capped most Mo models at around 128 experts, which means those awesome efficiency gains start to level off. And this is where things get really interesting. A new approach just completely blows past these limits by taking that specialist idea and pushing it to a crazy extreme. This new architecture is called PEER, which stands for Parameter Efficient Expert Retrieval. Now, don't worry, this diagram looks complex, but the idea is pretty straightforward. Over on the left, an input comes in and gets turned into a query. That query is then used to search a gigantic memory bank of tiny experts. The system finds the perfect ones for the job, and then their outputs are all combined on the right. The real magic, though, is in how it manages to search that massive bank so quickly. So it's basically a three-step dance. First, you transform the input into a query. Think of it like a super specific job description. Second, a hyper-efficient system zips through a massive database and retrieves the perfect tiny experts for that exact job. And finally, you mix the results from those experts to get your answer. It's almost like having an on-demand network of a million hyper-specialized freelancers ready to go at a moment's notice. You're probably thinking, okay, but how on earth do you search through a million experts without it taking forever, right? Well, that is a secret sauce here. The breakthrough is a clever technique called product key retrieval. It's basically a genius shortcut that lets the model find the best experts with something called sublinear complexity. All that really means is that even if you double the number of experts, the search time doesn't double. It grows way, way slower. And that's the key that makes this whole thing possible. And because of that efficiency, you unlock a completely different scale. We're not talking about a couple hundred experts anymore. We are talking about over 1 million tiny, highly specialized experts, all available on demand. This is a totally different way of thinking about how to build an AI. So, it's a really cool idea, right? But does it actually work better? Does a team of 1 million tiny specialists really outperform one big generalist? Well, let's take a look at the data. This chart right here is the aha moment. What you're seeing is a comparison of different models. The important thing to know is that for every point on this graph, the amount of computing power used is the same. The y-axis shows something called perplexity. Just think of it as an error score, where lower is better. Now, look at that teal line. That's PEER. It is consistently lower than the others, which means for the exact same amount of compute, it's getting better results. It's just plain more efficient. And to put some hard numbers on it, check out this table. A standard, dense model gets a score of about 18.19. The 128 expert MOE model improves on that, getting to 17.41. But look at Peer, with its million tiny experts. It comes in at 1499. That is a huge leap in performance for the same cost. Okay, so better performance for less cost is obviously great, but what does this actually mean for the future of AI? Why does this really matter? I mean, what does a future built on millions of tiny experts actually look like? This isn't just a small step forward. It really opens up some brand new possibilities for where AI can go. Well, for starters, it means we can get much more powerful AI without needing brand new, super expensive hardware. That's a huge deal. Second, it creates a real path toward what people call lifelong learning. Think about it. When a new scientific discovery is made, instead of having to retrain the entire model from scratch, you could just add a new expert on that topic. The AI could just continuously adapt and grow. And finally, it just gives us a much more flexible and powerful foundation to build the next generation of AI. Ultimately, what this all points to is a real paradigm shift. We might be moving away from the era of trying to build one single massive AI brain and into an era of orchestrating these huge, efficient collectives. It's like the slide says, the future of AI may not be one giant brain, but a chorus of a million tiny voices.
This is for entertainment purposes only.